Yeah, guys. The last Thursday I went to. I'll show you this one second. Uh, mm, something I have posted here. Yeah. So this is the events, guys. Something like Kubernetes. This is the Kube Day event. Actually, I already told you, right, guys? So initially, Kubernetes is developed by the Google, and it hand out to the who is guys. And the which organization it is hand out to the Kubernetes. CNCF. CNCF is nothing but a cloud native and a cloud formation. So this is the company is so conducted the event, keep the event. It is in held in India. So something like everyone in India they are coming on in this event and they are showing something like what are the new concepts, what are the new key features are coming onto the on the Kubernetes. They will assigning they will provide the information. They are conducting the webinars. Guys, understood? Yeah, so this is the Kubernetes in this. The sponsors are New Relic, Site 24/7. So these are the EY, these are the sponsors for the event. Guys, understood, right? Yeah. So what we discussed last time, we discussed about the control plane and the data plane, right? So this is the architecture of the Kubernetes. So you guys are watching the recordings? Guys, you guys are watched the recordings? No. So Kubernetes architecture is something like a control plane. It is a data plane. This both is nothing but a cluster. Kubernetes cluster is nothing but a worker plane. So the master node and the worker nodes are called as a control plane and data plane. It called as a cluster. So in the master node, so I already discussed about that, right? Master node and worker node. So master nodes contains a kubelet. Kubelet is responsible for what is the responsible for? It is the responsible for the scheduling and controlling everything. It is the controller to watch the pod is running or not, node is running or not. So this is very fine. So container runtime is nothing but a Docker service, right? In our Docker container, we are running the daemon, right? Docker daemon. So in container, it is a container runtime. Kubeproxy is nothing but it is a network part. So it will assign the IP address of the Kubeproxy to the master node. So master node, something like a master node and worker node, something like a master node contains what are the master nodes contains, guys. So this is the you guys are understood about the container runtime and kubelet and kubeproxy, what it is doing in the worker node. So every worker node, something like we have a here. So we have a two worker node, something like in the two worker nodes, kubelet is installed and kubeproxy is there, container runtime is there. The same way as kubelet, kubeproxy and runtime. Every node, every worker node having these three components. There is three components. For example, I have worker nodes or four worker nodes or five worker nodes. In every worker node, it is running the kubelet, kubeproxy, and container runtime. So what is the master node? Master node is something like having a API server, scheduler, etcd, controller, and cloud controller manager. So, so these are the four API. What is API server is doing? What is scheduler is doing? What is etcd is doing? What is controller is doing? So something like a worker node data plane is basically responsible for the running your application, right? So in here, so where your application is running on, where your application is running on something like, for example, Facebook, WhatsApp, whatever the application is running on the worker node. So worker node or a data plane. So this is the worker node or a data plane is basically responsible for the running your application. So running your application. Kubernetes for the deploying or creating the pods. What is that? Deploying and creating your pods by using the kubelet. Kubelet is the monitoring all the nodes and pods. So, proxy. So proxy is providing the networking, like generating the IP addresses, on your pods, like something like in Linux IP tables. So container runtime is providing for the execution of runtime of your environment. So if container runtime, if the something like a Docker is or container runtime is running, then only we can deploy, or we can start the containers. We can run the containers. So what is the master node? Something like I already told you, right? So support, something like a user is trying to deploy pod on the worker node. So this pod is nothing but just a ML file. So I will tell you guys, no worries. So something like a pod. So user is something like a trying to create a user is created a pod, but who will decide should be the pod is created or up on a node. For example, something like a prod is created. So who will decide? Core API component. So what is the core component, heart of the core API server? API server is decides, and the API server is decides something like API server said like that. So API server is the main. So core component of the Kubernetes is called as a API server. So are a master component. This is basically exposes your component. This is exposes your component. API server is a component, something like it will be external world and out of the Kubernetes of the API server. For example, API server such as, so which node is in which node we need to create the pod. Something like node one is free. So we are so something like API server tell. So you can create the pod in the node one. Who schedule this? So who schedule this? A scheduler. So something like a user created a pod, but who will decide should the pod is created on node one, or should the pod is created on node two? So this is a API server. API server node one is free. Who will so something like who will scheduler API server node one is free, but the schedule is that act on this. Who will schedule this? A scheduler is responsible for go and schedule this on node one. So who will decide? So something like API server will decide the where we need to deploy our pod. But who deploy? So something like a scheduler. Scheduler is responsible for go and schedule this or node 1 or node 2, it is receiving this from the API server. So API server said like that scheduler, you can go and uh, create a schedule to create a pod on the node 1. So who tells? API server tells. API server tells. So something like a then HCD. So what is the HCD? So HCD is basically act as a backup service. HCD is basically act as a backup service acting as a packaging store of the entire cluster information. So the entire cluster information will be available under the slash HC, something like a so HCD component. So HCD is basically act as a backup service or acting as a packing store of the entire cluster information. So HCD is called as a key value store. So HCD is called a key value store. Key value store, and the entire Kubernetes cluster information is stored as a objects or key values. The entire cluster, the entire something like a worker node 1, worker node 2, a master node, the entire cluster information will be the entire cluster information is stored as a object or a key values. Key values. Something like what is a controller? So what is a controller? Something like a controller. So controller manager basically as a replica set. Something like a how many pods are creating for the services. So for example, if it is a WhatsApp. In the WhatsApp, something like it. WhatsApp having the WhatsApp is one API server, one a database server. So how many app servers need to, how many app pods need to running, and how many database pods need to running? For example, so the replica set, the controller is responsible for something like a load balancing. How many pods will run on this app server. So or the DTB database server. So this is the controller manager basically controlling ensuring the running of the pods. It is something like a replica set. In that replica set, something like so two pods will need to run on that type server, two pods on the database server. So the control will contain will control that replica sets. Guys, understood? So this is nothing but a master node. Master node contains a API server, a scheduler server, etcd, and controller. So what is the API server? API server is the heart of the master server, and all the information will be available. Something like all. So this is the main component in the master node. So whenever we need to do anything, definitely we need to go to the API server, and we'll take the responsibility from the API server. Then we will schedule this service. Will schedule this service. Guys, understood, right? Right.
So what do you use the etcd and controllers to do after
Yes.
scheduling the service from the
Yes.
API
So
side?
HCD is the so all the information will be available. Something like HCD is basically act as a backup service or acting as a packaging store of entire cluster information. So the entire cluster, so master node, worker node one, worker node, the entire cluster information will be available under the HCD component. So the value is stored as a object or a key values. The values are stored as a object or key values.
Then controllers.
So the controller. So controller is something like a, for example, this is your, for example, this is your pod. So in the pod, something like a, we have a, these are the two containers are running. Something like a two pods are running. In the two pods, something like a, for example, this is one pod. This is one pod. In this one pod, having a one container. So these are the two containers are running on the, running on these two pods. So something like a, so in this controller is responsible for, so so how many replica set is nothing but a pods. How many pods running on this? So something like it is a load balancer or something like a replica set. Controller is nothing but a replica set. In the replica set, so replica set is nothing but a, how many pods are running on a service. For example, in this service, we are running the two pods. How many? So we are running the two pods. Yeah. So in this replica set call it as replica set having a two pods. The replica set, this is something like a AML file. Pod dot pod.aml file. So in this AML file, so the replica set is two. So how many pods? Replica set two is nothing but this is a pod one. So this is a pod two. So so how many pods are running? So who will handle this information? So this information will be handled by the controller. So the it is verifying how many pods are running. In the replica set, something like there is a two pods are running. So yeah, the two pods are running or not. So this should be controlled by the control panel. Understood? This should be controlled by the controller. So
So
who will
controller are these so controller are these images covering both one pod and two pod.
Yes, yes. So controller is responsible for, so in the replicas or something like a, so there is a request created in the load balance or something like a, so we need to run the two pods. So two pods. So something like this controller is validating in the replica set having two control something like a replica set is two, is the two pods are running or not. It will be validating the control. Understood?
Yeah.
Yeah. So this is nothing but a API server, scheduler, and etcd and controller. So cloud control manager is something like a, so cloud controller manager, CCM. So this CCM is nothing but a, So this cloud controller manager. So in this AKS, EKS or GE, Kubernetes, Google Kubernetes, this component is working on, this component will work on the cloud only. So I will tell you guys, I will tell you, no worries. This will be working on the cloud. This will be a cloud control manager. So the control, this is the architecture of the Kubernetes. This is the architecture of the Kubernetes. So deploy Kubernetes cluster using the Minikube. Something like we already told you, right, guys? Uh, Yeah. So Kubernetes something like so we can use the Minikube also in the local environment. So dev test QA environment purpose we are using the Minikube. So Minikube also known as a Kubernetes. Minikube also known as a Kubernetes. Deploy a K8 cluster using the Minikube. How we can deploy? Get our own cluster in our less than a 5 minutes. How we can deploy our Minikube?
Can you simply explain what this cluster means?
What is that?
Cluster.
Yeah, cluster, I already told you, right? So what is a cluster? So this is a cluster. So master node and worker node both together is nothing but a cluster. So in
Okay.
the cluster having a master node, worker node, something like a one worker node, one worker node, two worker node, three worker node, five worker node, six, something like a. So worker nodes are six worker nodes you have, and only one master node. These
So
are
what
both.
sorry, go ahead, Harry, sorry.
Yeah, yep, tell me.
So what does this I stand for the worker node? You know, when you started, I was not there initially, but it's okay.
So one, right?
This master node, yeah, that I, yeah.
For example, these are the three EC2 instances. These are the three EC2 instances. So you installed a master node in one node is nothing but a EC2 instance or VM. So master node
Okay.
is nothing but a one EC2 instance. Worker node is nothing but a one EC2 instance. A worker node 2 is nothing but another two EC2 instance. These three it is EC2 instances clubbed together, call it as a cluster.
Okay. So among these three instances, which one is under master node and the worker node? Okay, this worker node 1 and worker node 2.
Yeah. So
Okay.
worker node is nothing but so this is the master node or a something like a control plane. So this is the I already told you, right? Control plane, data plane. So control plane call it as a worker nodes, data plane it call it as a master node. Something like
Okay.
yeah. So master node or control plane. So data plane or a worker node. Got it?
So why is I got it. Why is the note, the third one empty?
No, this is nothing but a so same like worker node contains a data plane contains kubelet proxy. One second. The worker node contains kubelet proxy and container runtime. So another worker node also contains kube proxy, kubelet, container. So every worker node, so we have a three components. Those three components are kubelet, kube proxy, container runtime. So it is not a empty, just example. I'm writing the so I'm something like a I'm writing a line straight line, right? This is a kubelet, this is a kube proxy, this is a container runtime. For example, another
Okay.
node is there, worker node 3. So now worker node 3 having the three components, kubelet, kube proxy, container
Okay.
runtime. How many worker nodes you have?
Okay.
So there is a three components is installed on that machine. Understood?
Okay. And those three components can have those instances under it, like Kubernetes, Kube proxy, and container runtime in
These are
each
the
of those.
components. Components, kubelet, what what it is kubelet. So what is the purpose of kubelet? What is the purpose of kubeproxy? What is the purpose of container? If you
The
saw
same
my
thing.
old recording, so you will get all these.
Okay.
Okay.
Yeah.
Okay. So how to deploy a K8 cluster using the Minikube? So something like how you can, so two easy steps. One is install Minikube and install kubectl. So we need to install these two. So don't go anywhere. You have a something like a, you have just a minikube.siz. So there is a official document is there. You can go through that document and you can install it. Guys, uh, so this is the task I'm giving you to guys. We need to install tomorrow. So tomorrow we need to install kubectl and minikube on our VM or a something like or a EC2 instance. Okay. So you guys can watch these. So this is the kubectl, how to install the kubectl, and how to install kubectl. Yeah. So install kubectl on Linux. You guys can use this command. Use this command. There is a Kubernetes dot. What is this? Minikube. Minikube. Yeah. So this is the kubectl installation. So this is the one. It's getting started. Yeah. So this is the Minikube started. How we can install the Minikube? Something like you guys can install the Minikube on your Linux platform. You can download this and just so sudo install Minikube. You can install this Minikube. So then start your cluster. Or you can start Minikube start. So Minikube start. So after that you need to install the kubectl. How to install the kubectl? You guys can install the kubectl, right? Kubectl. So then we will so something like how many nodes are there? Minikube kubectl get pods. Pods is nothing but you can check the how many pods are there. I want to check the nodes. How many nodes are there? Minikube kubectl get nodes. You will get the nodes. Okay, you guys can use this command. So kubectl get pods. Kubectl hyphen describe something like you can get the create expose. So we will use the kubectl. What is a kubectl? Kubectl is a before also I already told you, right? Not here, it's here. Yeah, something like a Kubernetes architecture. So how we can connect this master node? How you can connect with this master node? You can connect with this master node by using a kubectl or something like a web UI. So web UI is nothing but a what are the web? So we can control this cluster. We can control this cluster uh, by using a web UI. So web UI is nothing but, for example, RKE. So RKE is nothing but a Rancher Kubernetes engine. So Rancher also providing the something like a UI Kubernetes services. The same like as a yes, Azure Kubernetes service. So this service also provides a GUI and EKS and GKE and OKE, Oracle Kubernetes Engine. So this is the Oracle Oracle K8s engine. So this is a Google K8s engine. So this is a EKS. So EKS is nothing but a Elastic Kubernetes engine. So these are the GUI. So you can deploy a application by using the GUI, something like GUI, and you can deploy the application by using the CLI also. CLI. So kubectl is the GUI. So something like a CLI. Same like as a Git, right? So Git is a CLI. You can use the Git commands by using the Git, or you can use the Git GUI. What are those? So something like a Atlassian company provides a Git, Bitbucket, GitLab, GitHub, Bitbucket. These are the GUI components. Same like as a how you can connect our cluster. So this is the cluster. Cluster is nothing but a group of master nodes, and worker nodes is classed as a cluster. How you can connect with these cluster? Either you can use the kubectl or you can use the WebUI RKE, something like RKE, something like RKE. I will show you RKE. You see? So this is the something like a Kubernetes RKE. So this is the RKE cluster. So you can see etcd, scheduler, controller, and nodes. So this is the Amazon EKS RKE, something like Amazon EKS. You can connect or RKE. You can connect it to the RKE. Yeah. You guys see. So this is the GUI. How many pods are running? These are the pods. When the pods are running, only one pod is running. The local one image. So it is showing in the GUI manner. So it is showing in the GUI manner. How you can get the pods in the say, kubectl, kubectl, get pods. It will show the pods. Cube,
It's a
cube.
command.
Yes, it's a command based. Kubectl get node. Gets node. It will show the list of pods and it will show the list of nodes. Something like I will show you guys. I will show you.
Basically, using the GUI, we can see the GUI also, right?
Yeah, GUI also. So get pods.
Directly without commands, we can see the all the list of the pods and
That's the reason.
everything. We
That's the
can
reason.
see.
Yeah, you see, this is the way you can see it. So this is the
Okay.
way. So in the GUI manner, this is the pod. You see, this is the pod. But how you can get it in the get so kubectl get parts wages. Yeah, you see. So this is the command minikube start. Yeah, kubectl get parts. How many parts are running? How many parts are completed? So these are the parts running. So these are the parts running in GUI. So this is running. So in GUI we can see it here. It is same. In CLI you can see here. You can see how many parts are running, how many nodes are running. Something like a get nodes.
Okay, in real time, which is most useful, means most companies are using
Yeah, I'm
CLI or
using in my company are using RKE, and we recently we migrated to EKS. So all are the companies are using only UI. Okay, only web UI. So these are all are the companies are using web UIs only. Okay, guys,
Yes,
you
yes, go
understood,
ahead.
right? So something like a git. So we can execute the commands by using git add, git commit, git push, git pull, right? The same way also we can use the we can connect to the remote repository, something like GitHub, and we can create a file and we can push the file and we can merge the file by using the GUI also. So we can connect we can so the this way we can connect the cluster through kubectl or web UI. Now you got it, right, guys? Got it?
Yes.
Yes,
Yes,
right? Yeah. So what is the task, guys? I gave you task like, so we need to install the Kubernetes on your local VM. You guys can do it. You guys can do it.
Can you paste those commands or like just indicate it somewhere easier for us to actually access while trying to install the
This one, right? That the document, right?
Mhm. I know the document might be there, but like, just make it visible for us to be able to see it easily instead of searching.
Yeah, yeah. You can use this document, guys. Minikube .sys.k.io. So this is the documentation. You guys can install the Minikube on your local desktop or something like a local VM or something like you can install on the AWS EC2 also, guys. Okay.
Okay, so this installation is gonna be on the AWS or the I think we're gonna install it on the Oracle VirtualBox, or is it in AWS?
No. What I am saying is you can take the two EC2 instances. You can launch the two EC2 instances. Okay.
Okay.
On that you
That's
can.
what you mean by installation?
Yes.
Oh, okay. Got you.
Got it, right?
Mm.
Yeah. So you guys can install it, and this is the you can use it kubectl or you can use it. So you guys in test, right? Test or something like a dev environments, right? You guys can use the kubectl get pods and kubectl get nodes. So something
Then
like a what is
one more
yes,
question. In
yeah.
AWS, do you have the kubectl or WI on how to connect to the server when you want to install it?
Yeah, so that is so guys, so you can install on the Kubernetes on the EKS, no worries in the AWS. But just
Oh,
you can run the Minikube first. You understand the concept of the Kubernetes, then you can run. Then you can
any of
install
them.
the EKS on something like GKE. So if you sign up the Google Cloud, they will give the some credits. So you can use that credit and you can launch that Kubernetes engine on Google. Then you
Mhm.
can work on that. Okay.
Okay. So what
Yeah.
about the like Tutti Michael if you want to choose the the if you want to
Yeah,
choose
you
the
can.
source? So How do you do it?
You can run on the Tutor macro. It's enough.
Okay.
Okay. Or you can install it on the your virtual machine. Yeah, you can install two virtual machine, something like a CentOS or whatever it may be, and you can run these commands on that CentOS machines. Okay, you can try it. You can try it. You got the something like if you are facing any issues, please let me know. So I will show you tomorrow or day after tomorrow how to install the kubectl minikube on that machine. Okay.
Mm.
So something like a what is a pod in the Kubernetes container? It call it as a pod, right? So container it call it as a pod, but in the Docker they call it as a container. They call it as a something like a container. Why in Kubernetes? So container is calling as a pod. Something like in the pod we can in the pod, so we can run a one or group of containers. So what is a pod? So pod is something like a pod is nothing but it's a something like a mm, Docker information. How we can say that something like a the specification of the specifications, right? Docker run -d it something like -p expose. So how much something like 880 expose something like a name everything. So everything will run on the same commands, right? We can run on the multiple commands while running the Docker, but we can specify it in the one document. We can specify it in the one YAML file, something like a specifications or what are the exposures, what are these in the specifications. So something like API version. So then specifications. In the specifications, you can run the how many containers and what are the specifications we need to run. So everything a pod is nothing but a YAML file. Pod.yaml is nothing but a pod. In that pod, you can specify the how many containers are we need to run. Something like a Docker run. So in Kubernetes, we were not running the manual commands. We will run everything through the YAML. We run everything through the YAML files. And something like a pod is nothing but pod is nothing but pod YAML is nothing but a so specifications in the container. How many containers? What are the exposures? Or what are the name? What are the port number we need to enable? IT is enabled or not? So we can provide it in the pod.yaml. So pod contains a single or multiple containers. Pod contains a single or a multiple containers. So why multiple containers? So YAML something like a pod or a something like a deployment. Pod or a deployment. Pod YAML or a deployment YAML. So for example, so a pod contains a one or group of content, one or a group of container. So this is the pod. This is the pod. This pod having the containers. So something like what are the containers in the group of containers, something like a sidecar containers, init containers. I will show you guys. These are the config files. So later we'll show you something like so this is the pod A and pod B. So pod A and pod B, something like we need to resource. So here, so this is this is the pod A and pod B. So pod A and pod B, it is in the something like a container A and container B in the pod. So container A linked to the resources of a network, something like it will be shared network. It will be sharing the sources. It will be sharing the files also. Something like these two containers. So will expose through the localhost 30, something like a local host. So there is no IP address for these two containers. But in our container there is IP address, right? So there is IP address. But here, so a cluster IP, pod cluster IP will be used for these two containers. Will be used for these two containers. So a pod cluster IP. So this is the container, a container. So pod is nothing but a wrapper, a type of DevOps to see easy. Something like how you can run the exposures that. So YAML git pod.yaml. Something like in the GitHub that a pod.yaml is there. In that pod.yaml, something like 88 is the statement and the mount points. Everything will be located in the pod.yaml file. What it contains, what are the containers are there. So it will be showing on the pod. It will be showing on the pod, guys. It will be showing on the pod. Yeah. So we already told you, right, guys? So what is a HCD? What is a scheduler? What is API server? So something like Kubernetes master. Master is responsible for managing the complete cluster. You can access the master node via CLI or GUI or API. I already told you. So the master watches over the nodes in the cluster. The master watches over the nodes in the cluster, and it is responsible for the actual orchestration of the container on the worker node. For achieving the fault tolerance, there can be more than one master node in the cluster. It is the access point from the which administrator and the other users interact with the cluster to manage the scheduling and deployment of the content. So it has the components of HCD, scheduler, and controller and API server. So what is the Kubernetes architecture? In the Kubernetes architecture, what is the in the Kubernetes master? What is HCD? HCD is the distributed reliable key value store used by the Kubernetes to store all the data used to manage the cluster. So when you have a multiple nodes and multiple masters in your cluster, HCD store all that information on the nodes in the cluster in the distributed manner. HCD is responsible for implementing the lock which is in cluster to ensure there is no conflict between the masters. Scheduler. So what is the scheduler? The scheduler is responsible for distributing the work or container across the multiple nodes. It is for newly created container or assigning them to the nodes. So what is the API server? So API server masters communicate with the rest of the cluster through Kube API server. So the main access point of the controller plane is API server. It validates the execute the user's REST commands. Kube API server also makes sure that the configuration is HCD match with the configuration of the containers deployed in the cluster. So what is the controller manager? The controller manager are the brain of the behind the orchestration. So what is this? A brain of the behind the orchestration. API server is the heart of the orchestration, masters node. So they are responsible for the noticing and responding when the nodes, containers, and endpoints goes down. The controller makes decision to bring up new containers in such cases. So a kube controller manager runs the control loops that manages the state of the cluster by checking the required deployments, replicas, and nodes are the running the cluster. kubectl. So what is the kubectl? Kubectl is the command line utility using which we can interact with the Kubernetes cluster. kubectl is the command line utility using which we can interact with the Kubernetes. Uses API providing by the API servers to interact, also known as a kube command line tool to our kubectl or kube controller. Used to deploy and manage the applications on the Kubernetes. kubectl run nginx. It is used to deploy an application on the cluster. How you can deploy application on the cluster, how you can deploy nginx pod or nginx pod on the system container on the server on the Kubernetes by using a kubectl. Run is the command. Kubectl cluster info, it is used to information about the cluster and the others. Kubectl get nodes, used to list of the all the nodes part of the cluster. It is used to list all the nodes of the part of the cluster. Kubectl get nodes, kubectl get pods, kubectl get describes. Yep. So Kubernetes worker. So in the worker node, kubelet, kubeproxy, we already discussed it, right? Kubernetes, or what is K3s? K3s is a fully compliant Kubernetes distribution, which is the following of enhancement packaged as a single binary, 100 MB memory footprint, support ARM and x86 architecture, low weight storage backend based on the SQLite as a default storage mechanism in the replica behavior HCC service. Docker is replaced in the flavor of the container D runtime. Inbuilt ingress controller. So something like a mini cube, something like this is a mini cube. How to set up using a virtual box. So how to set up the mini cube using the virtual box. Guys, I already told you, right? What is a pod? Pod is nothing but a basic scheduling unit in Kubernetes. Basic scheduling unit in the Kubernetes. Pods are often as a imperial or a doc or a container. Kubernetes does not run containers. Kubernetes does not run containers directly. Instead of it wraps one or more containers into a high-level structure called as a pod. Kubernetes does not run containers directly. Instead, it wraps one or more containers in a higher level structure called as a pod. It is also the smallest deployable unit that is can be created, scheduled, and managed in the Kubernetes. So we can create and schedule and manage on the Kubernetes these pods on the cluster. Each pod is assigned to a unique IP address within the cluster. So pods can hold multiple containers. Pods can hold multiple containers as well, but you should limit yourself when possible, because of pods are scaled up and scaled down as a unit. Pods are scaled up and scaled down as a unit. All the containers in the pod must scale together regardless of their individual needs. This leads to a wasted resources. So maximum we can run on every pod in on pod one container. So something like this is a pod. This pod container say so WordPress container, MySQL container, some other container, right? Pods. So any container in the same pod will share the same storage volumes. I already discussed in this. So any container in the same pod will share the same storage volumes and network resources and the communicate using the local host. We can communicate using the local host. So K8s uses YAML to describe the desired state of the container in the pod. This is also called as a pod spec. So pod spec is nothing but a specification. Pod spec is nothing but a specification. Specifications. So these objects are passed through the kubelet through the API server. Pods are used to the unit of replication in the Kubernetes. Pods are used as the unit of replication in the Kubernetes. If your application becomes too popular and the single pod instance cannot carry the load, Kubernetes can be configured that deploy new replicas from your pod to the cluster as a necessary. Scaling the pods. How you can scaling the pods? All containers with the pod get scaled together. All containers within the pod. All the containers within the pod get scaled together. You cannot scale individual containers within the pods. The pod is in the unit of scale in the K8s. A recommended way to have only one container per pod. So multi-container pods are very rare. So in K8s, init container is sometimes used as a second container inside the pod. So what is that? So I already told you, right? So something like init cards, side cards, init card. So this is the way I told you. So init container is sometimes used as a second container inside the pod. So something like a pod in container one, container two. Scale up something like a pod one, pod two, pod three. So if you want to add a replica set in the three pods, something like we can create a four pods with the four containers. So init container exactly like a regular container, except that they always run the completion. Each init container must complete successfully before the next one starts. If your pod init container fails, Kubernetes repeatedly restart the pod until the init container succeeds. Init container succeeds. So Kubernetes imperative versus declarative. So declarative, right? Declarative meaning is nothing but a. So this is the declarative syntax. This is the declarative syntax. So declarative versus imperative. So imperative versus declarative commands. Kubernetes APIs defines a lot of objects and resources such as namespaces, pods, deployment, services, secrets, config maps. What are those namespaces, pods, deployments, services, secrets, configs, and maps? There are two basic ways to deploy objects in Kubernetes. One is imperatively way, so the other one is declarative. So imperative is nothing but involves using any of the web-based commands like kubectl run, kubectl create, kubectl expose, kubectl delete, kubectl scale, kubectl edit, suitable for testing and interactive experimentation. So declarative objects are written in the YAML files and deploying using the kubectl create and kubeapply, best suited for the production environments. What are those? Imperative versus declarative. Declarative is best suited for the production environment. Best suited for the environment. Kubernetes is something like a manifest or a spectre. So we'll discuss on this on tomorrow, guys. So once we install the mini kube on our server, right? So then we will discuss this. manifest files and manifest man files, guys. Okay, so what are the commands? kubectl version, kubectl get nodes, kubectl get pods, cluster info, get pods. So we can use these commands. I will show it on the tomorrow. So maybe tomorrow and after tomorrow we will close the Kubernetes, guys. Guys, you guys somehow you guys are able to understand the Kubernetes concept, right, guys? So tomorrow we will install the Kubernetes and we will show you to the how to deploy pods and how to get the pods, how to get the nodes and to create and how to apply the pods. So we'll show it on tomorrow and after tomorrow, and we will close it the Kubernetes, guys. You guys can explore the Kubernetes. You guys are understood about the basic idea, right? That Kubernetes. Okay. So after this, we will start the Jenkins CI/CD. So the all the tools are completed. So we can integrate that all the tools on the Jenkins and we can deploy automate. Okay. Guys are understood, right?